me, Miss Carter. I wanted to hop on here today and make a video for you of your notes. You guys took notes yesterday on reviewing your right triangle SOHCAHTOA stuff. And then you had notes today that had some examples for you. So what I wanted to do was to kind of read through the notes and explain them, because I already know writing this down, just copying it word for word and putting all the examples down isn't going to make sense if there isn't some sort of explanation behind it. Now, again, if any of you haven't heard me say this before or happen to have forgotten, please feel free to look these things up on Khan Academy. That's Khan Academy. They have millions of videos and tutorials and explanations for ways that you solve mathematical problems, all kinds of stuff on there that's super, super helpful, and it's free. So please go to Khan Academy online and look that up if you're ever confused about something. You can also Google or YouTube tutorials to explain what sine, cosine, and tangent mean, what they do, what they are. But nonetheless, I still wanted to explain my notes for you guys. Because what I do when I take these notes is I've looked at other notes, other practice pages, different things that it is, your objectives, your standards, and tried to put it in the easiest form for you so that when you look at your notebook, there's not too much information, but what you need to know is there, and it makes sense. So let's take a look, and I'm just going to show the notes on the screen and just go through it, pointing out different parts and explain each piece. So let's get to that. So yesterday's notes, titled Review of Right Triangle Trig, started with, I guess, just a nice, easy way to remember which operation uses certain sides of a triangle. So when you have a right triangle, you'll know that it's a right triangle because there's going to be one of these squares in the 90-degree angle every time, and that represents 90 degrees. So when it's a right triangle, you should see that square, that right angle will be given to you. So there are ways using your angles and your sides to figure out missing sides and angles. And the three operations that we use are sine, cosine, and tangent, and I put them over here, the actual operation or the function, and the two sides that it uses. So the sine function uses the opposite side divided by the hypotenuse. The cosine function uses the adjacent side over the hypotenuse, and the tangent function uses the opposite over the adjacent side. But sometimes we forget which function goes with which side. So we can always remember it as some old hippie caught another hippie tripping on acid. And I've heard this since I was in school, so it's been around. And the first letter of each word helps us remember the sides that go with the function. So some old hippie is sine, opposite over hypotenuse. Caught another hippie is cosine, adjacent, hypotenuse. And tripping on acid is the tangent, opposite, and adjacent. And remember that it's this divided by this every time. And so out beside each one, I gave you an example. So sine of the angle, and the angle is like this little angle right here. If you wanted to find sine of that angle, well, you have to find the opposite side and the hypotenuse side from that angle. So when you're standing, imagine you're standing in one of these triangles. The opposite side will be the side across from you on the opposite side of the triangle, so that would be 12, over the hypotenuse. And the hypotenuse is always directly across from your right angle. So it would be 12 over 15, which just reduces. So wherever the angle is that they're asking you about, imagine yourself standing there and looking out and finding the sides from that point. So you always figure out your opposite, hypotenuse, and adjacent side from the angle that they're asking you for. So it can be different in every triangle. So for this example, beside our cosine, I asked for the cosine of this angle. So from this angle, you would look for the adjacent and hypotenuse. So adjacent is the one that's right next to it. So you can kind of see there's an arrow pointing to this side right next to it. And then hypotenuse is always the one directly across from that right angle. So it would be 3 over 5. And then tangent is your opposite over adjacent. So again, start from the angle that they've asked you for. So they're asking from this angle, find those sides. So opposite is all the way over here. Adjacent is the one right next to it. So it would be 8/6, which just reduces. So the first thing you have to do is be able to identify your sides. You're never going to be able to figure out which operation you use if you don't know how to label your sides. So that's one of the most important things to start with. Any triangle, they're going to ask you for either a missing side and give you the angle, or they're going to ask you about a missing angle. But you've got to start in that angle that they're talking about and look out and label your sides. Opposite will always be across from the angle that they're asking about. It will be on the opposite side. Your adjacent will be the one that's right next to it, and that one can easily get confused with your hypotenuse, because if I'm standing here, yes, this is opposite of me, but it looks like either one of these could be next to me or adjacent to me. But if you know your hypotenuse is always across from your right angle, that can no longer be adjacent. It has to be your hypotenuse, leaving the only one left to be your adjacent side. So it's typically easiest to find your opposite side and your hypotenuse, and whatever's left is your adjacent side. So those are the three types of sides you can have: opposite, hypotenuse, and adjacent. Now there's two types of questions they could ask you. They're either asking you for an angle that's missing or a side that's missing. So I gave you two examples here. Let me zoom out some. Here we go. So if they're missing an angle, you're going to use an inverse function. And that would be where you have the power of -1. It represents an inverse function. So on this triangle, there's always three things that are going to be given to you. So on this triangle, we have two sides and an angle. One of the three things will be missing. You will always have your function or the operation you're doing right here, sine, cosine, or tangent, followed by the angle, set equal to side over side. So if we were to go back up here, the operation, your angle would go there, and then you've got your two sides every time. Your operation and your angle set equal to two sides. So when you're missing your angle, your x is always going to be right beside the function because that's where the angle goes. So we don't know it. So from this angle, once I know that they're asking me to find this, I put myself here in this triangle and I looked out and I figured, what are these two sides? From this angle, 5 is my opposite side and 10 is my adjacent, because that's got to be my hypotenuse across from the right angle. And they didn't give me that, so I don't need that. So from this angle, I have opposite and adjacent. So O and A would be tangent. So that's how I figured out that I was doing tangent of my angle, because I looked and figured out what sides I'm using. So when I write it down, it's function, angle, side, side. I know the function is tangent, the angle is unknown, and the two sides are opposite, 5, over adjacent, 10. Now, when we solve for x, we have to get it by itself. So you have to move this function to this side. Anytime we move something across the equal sign, the sign changes. So that's why it becomes an inverse. So you would just type in inverse tangent, 5 over 10. And this reduces down to 26.56. And I'll show you how that happens on Desmos. Desmos, you have to make sure that you go to the top right corner and click graph settings and make sure that you're in degrees. If you're in radians, it will not work. And then come back over and click on your keypad. And if you hit the functions button, you can look at all your trig functions, and they're all right there. So if I wanted to do inverse tangent, it would be this one, the tangent to the -1. And over here, you'll see all you have to do is type in your 5 divided by 10. So we have 5 divided by 10. We get 26.5 is that missing angle. So you guys can use Desmos calculator to solve all of these trig problems. So let's go back to our notes. Just wanted to show you how to do that. Let's look at missing sides. So anytime you're missing an angle, your x or your angle will not be there, and you've got to move this to the other side. We're always solving for x, and you've got to get it by itself. So for missing angles, you'll always be using these inverse functions, no matter if it's sine, cosine, or tangent. But if you're missing a side, it's going to be a little different. So again, if you look, these are still all set up the same way. Function, angle, side over side. Function, angle, side over side. That will not change ever. What changes is where the x is located. So again, every right triangle, 3 things will be given to you, 2 sides and an angle. One of those 3 will be missing, and you've got to figure out which one's missing and put it in the right spot. So for this example, we have an angle and 2 sides. So again, you need to put yourself in that angle, whether they give it to you or not, just like this example. You still put yourself right here, and imagine you're standing here, and look out and say, what are these 2 sides in relation to me? Well, x, it could be adjacent, right? It's beside me, but 14.5 is also beside me. So one of these has to be my hypotenuse, and that's going to be the one across from the right angle. So x is my hypotenuse. 14.5 is right beside me, so that's adjacent, which means I'm working with adjacent and hypotenuse, A and H. A and H is cosine, so I have to do adjacent over hypotenuse. So that's why I chose cosine of my angle, because the 2 sides I'm working with are adjacent and hypotenuse. Make sure you put them in the order they go. Cosine is CAH, adjacent over hypotenuse. The rule that we remember for any time you're missing a side is that wherever your x is, you're either going to have to multiply or divide. So if your x is high, you multiply, meaning if it's up top. If your x is down, you switch it around, meaning if your x is on the bottom, just switch these 2. Again, our goal is to always get x by itself. That's how we solve for x in any situation, no matter what type of equation you're working on. If you get x by itself, you should be able to solve for x. So instead of having it over here, we're going to switch these 2 around, and it will be x equals 14.5 divided by cosine of 37.9. This can be typed in the calculator. You would just go back to Desmos again, type in 14.5 divided by, and use the trig function button and choose your cosine. And it will simplify that answer for you. And then here's another example. From this angle, if you're standing here, what are the 2 sides that are given? Well, we've got our hypotenuse and our adjacent. I just switched where the x was. So when we do cosine of our angle, it's CA. It's adjacent over hypotenuse, so x over 14.5. When x is high, just multiply the 2 values that you do have, and that way x is by itself, and it'll give you the answers. So this is what that whole page meant. It was just letting you know these are the 3 types of functions you will have, sine, cosine, or tangent, depending on the 2 sides that you have. So from the angle that they give you, or they may not give it to you, it may be a missing angle or an angle that's given. From that angle, identify your sides that you're working with so that you know which function you're using. Sine uses opposite and hypotenuse, cosine uses adjacent and hypotenuse, tangent uses opposite and adjacent. And then once you've figured out and labeled your sides, you need to set your equations up. Function, angle, equals side over side. Function, angle, equals side over side. Function, angle, equals side over side. Once you've set everything up, look and see where is my x located. If I'm missing my angle, I need to move that function over and use an inverse function. If I'm missing a side, I need to look and see where is that x located. If x is high, just multiply the 2 things you have. If x is down, just switch it around and do a division problem. So that was yesterday's notes. I'm hoping that was helpful and it made some sense just to have me kind of explaining how the notes work. And now I'm going to go over today's notes as well. They were right triangle examples, so it was actually working out from your right triangle, what sides do I have? Am I missing my angle or am I missing my side? And how do I solve this? So there were 5 examples, and I will show them to you now, because again, just to copy it down, you don't actually get to see what part I did first or how I moved from one part to another part, so I'm going to explain that. I may not go over every example here because some of them are a bit repetitive, but I'm going to explain kind of how the notes work and what kind of what was the point of showing you these examples, and you know, whether you were looking for a missing angle or a missing side, and how did we actually solve that. So let's take a look at today's notes. I wrote up at the top of today's notes exactly what I have said multiple times in this video. You will always have, whatever your operation, your function is, sine, cosine, or tangent, the angle, and set it equal to both sides. Every time it will look that way. Now, one of these three will be missing, as I've also said. So we look at the first three examples were missing angles. Again, I'm just going to go over two. So from this triangle, I noticed that they were asking me sine of A. Now in this example, they gave me all of my sides, all of my angles, A, B, C, 8, 6, 10. So every angle is labeled, every side is numbered. So I had to look here and say, okay, they want me to find sine of A. So I need to start at A. So angle A is right here. And I know that sine is opposite over hypotenuse. So I need to find my opposite side, that's this one, and my hypotenuse across from the right angle, leaving this to be my adjacent side. Now, because sine only uses opposite and hypotenuse, I don't need to use this side. I just labeled it because it's correct, but I don't need to use it. So it's going to be opposite over hypotenuse. So sine of A is 6 over 10. Okay, so if you wanted to actually solve this, you would just do a inverse operation to get A by itself. I would move this over, and on Desmos, I would do inverse sine of 6 over 10, and we can figure it out. And again, I put use opposite over hypotenuse because sine is so, the SOHCAHTOA, sine is the so. Sine opposite hypotenuse. That lets you know which ones to use. So let's do the inverse sine of 6 over 10 on Desmos and see what our answer is. We go down here and choose functions and choose our inverse sine, 6 over 10. It's 36.8 would be our angle. Super easy. Now if we were to look at the next one, again, they labeled A, B, C, and they labeled all the sides, and they asked you for cosine of A. So that means I've got to start at angle A, and I need to label my sides. So this is the opposite side, and then this is right next to me, and this is my hypotenuse because it's across from the right angle. So I've labeled them all, and I need to understand which two sides cosine uses. So cosine of A would be adjacent over hypotenuse, so it would be 16 over 20. So I would do 16 over 20. Sorry, that wasn't in your notes. I didn't fill that in. So it's operation, angle, side over side. I would use adjacent over hypotenuse because cosine is adjacent and hypotenuse. So COHCAHTOA. So those are the two sides I use. Again, you can enter the inverse cosine of 16 over 20 into Desmos and get your answer, or figure out what that angle would be. The last examples I showed you on how to set these up were missing sides. So they give me angle A, B, C, and then only two sides. So when you're looking at this, again, they asked me for the sine of 21. So they're already telling me what two sides I need to be using, and they're telling me what angle to start in. Sometimes that won't be the case. You just have to look and see how are they wording it, what do they want you to do. So 21 is right here, angle 21. So from this angle, sine is opposite over hypotenuse, right? So the opposite is x, it's across the triangle from me. And the hypotenuse is across from the right angle, it's 9, so it would be x over 9. So sine of 21 is x over 9. When x is high, we multiply, and I put that right here. So it would actually be these two things that you have multiplied together will give you x, 3.22. And then down here, cosine of 50, well, from angle 50, cosine is adjacent and hypotenuse. So that would be these two sides. So it would be 20 over x. Because x is down, we just switch these around, and it's actually 20 divided by cosine of 50, not divided by x. And that simplifies to 31.1. So these were just some examples to show you how to actually set them up from the examples given. Okay, I'm sorry today's video was a lot longer than most, but I kind of covered 2 days worth of notes all in that, and it was the beginning of a unit. So this is the first time in our class that we've done anything trigonometry related. Not to say you've never seen this before. So you have done these things before. It's just been a while. So we had to recap and kind of help us remember, how do we solve right triangles? What are we looking for? We know that one angle is always 90 degrees. So we've got to figure out the two others. And we can find missing sides and missing angles with sine, cosine, and tangent. And you'll hear me say SOHCAHTOA a lot because it's the acronym that helps me remember what sides go with each function. SO is sine opposite hypotenuse, CA is cosine adjacent hypotenuse, and TOA is tangent opposite and adjacent. And so that's how I remember. So good job copying down your notes. Thank you guys for uploading them to Classroom so that I can see that you're getting your notes done. Here soon, towards the end of the week, you guys are going to get some practice, either practice papers or some online practice to start solving some of these right triangle problems. So make sure that you're taking the notes, that you're understanding, that you're either watching this video that I upload for you, or you're going on YouTube or other sources to make sure that you're understanding it. What I don't want you to do is just copy down the notes, upload it, and then never look at it or think about it or try to really grasp what you just wrote. That's not going to be very beneficial. Again, with online learning, there's a lot of personal responsibility that you guys have to do on your own because I'm not there to help you. So watch all the videos you can watch, take all the notes you can take. If you guys want, you can do Zoom calls with each other to help each other explain things. Sometimes when you hear it from a classmate, it makes more sense than when you hear it from a teacher. So hopefully this video helps. Always comment below if you are still confused about something or need something else from me. If you need me to explain something, just let me know. Anyways, miss you guys. I hope this video is helpful, and I will be talking to you guys soon. Bye.